So here we go. Hey everyone, it's Mr. Canfield. Today we're going to do techniques of differentiation. So we got a nice wall of text up here. There's some cool stuff there. Feel free to read it. I'm going to move on. Okay, so remember that the derivative differentiation is like the verb form of derivatives. Like if you want to take the derivative, you're going to differentiate. So remember that the derivative is the slope of something. So all of these come back to, if you know the slope of something, then you know its derivative. So for example, y equals 9. What shape does that make? Woo, flat line. Hey, what's the slope of this line anywhere? It's always flat. The slope of this is always 0. Therefore, y prime is equal to 0. The constant rule. The derivative of a constant is 0. That is, if c is a real number, then d dx of c is equal to 0. From a geometric point of view, the graph of y equals c is a horizontal line, and at any point along the line, its slope is 0. This is all true and very, very helpful, but you're not giving me that YouTube view time for me to read to you. So like for our next one, if f of x is equal to 0, well, what's the slope of a flat line always? Oh, 0, so f prime is equal to 0. For all of these, it is possible to plug them into the f of x minus h formula. You can do all that. I mean, sorry, f of x plus h, you can do all that, but you get 0. So surprise, s prime of t is equal to 0. Hey, we switched it up. We used a different variable. Who cares? And then, 1 over pi cubed. Wait, pi's a number. So 1 over a number cubed. If I went into my calculator and I said 1 over pi cubed. Oh, I'm going to switch. I'm still in classic mode. Let me go back to math print. You can't even see it. It's too close. It's having a hard time graphing it. All right, hard time graphing it. Let's. There it is. Whoa. Oh wow, it's a flat line. The slope is still 0. That was challenging. No, like that's weird. But once you realize it's a number, it's not difficult. Okay. So next line. So I'm not going to read this yet. It says y equals x. Oh wait, this is a line. It's a line that goes like. What's the slope of the line? The number that's on the front of x, right? So what's y prime? The slope of the line. It doesn't matter where you look at on that line. If we look at the line y equals x, anywhere along this line, the slope is up 1 over 1. The slope is 1. And so that means that y prime of x, no matter what, is 1 every single time. Similarly, f of x is equal to x. Remember that y and f of x, they're the same thing. But we don't say we don't write y prime this time. We'll write f prime of x is equal to 1. All right, this one's also super challenging, so be careful. I'm just kidding, it's the same thing. S prime of t is equal to 1. It doesn't matter what the letter is. What matters is that the left-hand side is in terms of the right-hand side. So like how these two say f of x and s of t, and then that's an x and that's a t. This says g of big T. That means that g prime of t is still 1. We get into strangeness if we were to have something like f prime, or sorry, if f of x was like equal to y. Now we start having a problem because where's the x over here? There isn't one, and that starts to get a little bit strange. So, yeah, we'll see stuff like that later this year, but don't worry about it right now. Okay. So just in case you missed it, the derivative of x is 1. d dx of x is equal to 1. This is consistent with the fact that the slope of the line y equals x is 1 at any point on the line. Wow. And like, to be fair, if we had like y is equal to 3x, what's the slope of y equals 3x? Guess what? It's 3. Hey, what's the slope of y equals 3x plus 4? What's the slope of this line? Still 3. The derivative of this is 3. Okay. Moving on. Okay. I'm going to show you what it is for the first 3 of these, and then I'm going to tell you how it works. So in A, it says y equals x squared, so y prime is equal to 2x. And this might not be readily apparent, but it might start to show itself in B. In B, f of x is equal to x to the 6th. F prime of x is equal to 6x to the 5th. I think this is a very, very good example. So predict for yourself what's going to happen in this one. It says t to the 30th. So s prime of t, let's see if you got it right, 30 t to the 29th. So in case you've missed it, this is called the power rule, and if it's just x to a power, instead of having to go through the definition of the derivative, which would work, but think about this. When we had to do the x plus h squared, we got x squared plus 2xh plus h squared. It was annoying. Try doing x plus h to the 6th power, or to the 30th power. Thankfully, we don't need to. People figured out this pattern, and there are proofs, which I don't do the proofs in class usually, but there are proofs to show that any polynomial, or sorry, any like x to any power, when we take its derivative, it's always bring the power out front and then subtract by 1, and that's the new power. It even works for something like this. We just have to recall some old things. We have to remember, oh yeah, the square root of x is equal to x to the, ask your brain. What's your brain say? The square root of x is x to the, if it said the 1/2 power, then you can trust your brain on this. If it said anything else, remember, your brain's not quite there yet, and we want to be careful in the future. So the square root of x is x to the 1/2. So if I was going to follow this, what we call the power rule, then I'm going to pull the 1/2 out front. We bring it down. We multiply by that 1/2. It's going to be x to the, and we're going to subtract 1 from this. So let's think about that. 1/2 minus 1. Well, the 1 is like a 2 over 2, so we wind up getting negative 1/2. And we generally will clean this up since it's a negative exponent. Remember that negative exponents flip. So we would go 1 over 2, and then we'd have an x to the 1/2 down there. So the 1 and the 2 stayed where they are, but the thing with the negative exponent flipped. So, and then he says it really well. In general, we prefer to leave answers with positive exponents. And prefer, I'm going to put in quotes. If you can't turn it back to something with positive exponents, a lot of times you won't be able to find the correct multiple choice answer. So these are both technically correct for y prime in this situation. But only one of these is going to show up on a multiple choice test, and it's going to be this one. Or it might even be 1 over 2, and then instead of writing x to the 1/2, we can rewrite that as the square root of x. This is actually personally how I prefer to write it, but it's either of these is kind of the acceptable form. This is more of an unacceptable, kind of deemed messy, or just not going to show up on multiple choice. Okay, so anyway, all of these, they may look impossible, but it turns out these are all rather simple derivatives to take. We just have to remember that negative exponents flip, and to take something out and have it not look like a flip, we just change it to a negative exponent. So like, I could rewrite y as y is equal to x to the negative 1 in this situation. And now I can just follow the derivative rule, the power rule. Y prime is equal to negative 1, x to the negative 2. And so I do want to clean that up and write negative 1 over x squared. But there we go. Our next one, we can rewrite f of x to say x to the negative 3, right? To unflip an exponent, throw a negative exponent in there. So f prime then is going to be negative 3 x to the negative 4. Remember, we're subtracting 1 from these exponents, so that's why that's happening. Then I want to get rid of the negative exponent though. The steps that I'm showing are not required. There are people who can look at these and they can tiptoe through the steps in their brain and then write the answer. 100% acceptable. I'm never going to tell you you have to show steps that you don't need to do, that you don't need to write down. There's always this back and forth of like, hey, do you really want to skip in this one and say, oh yeah, s prime of t is negative 1 over 3 t to the 2/3? Like, do you really want to do that? Are you sure that you did it correctly? So instead of trying to, like, it's all well and good to do things in your head, but if you're just trying to show off, it's a dangerous use of your time. You might be better off being careful and not flexing quite as hard on people. So, like here, I'm going to say this is, okay, so that's t to the 1/3 down there. So then that means if it's 1 over that, I could say this is t to the negative 1/3. So, oh wait, that's regular s of t. That's not s prime. That's regular s. I just rewrote it to think about it. So now when I find s prime of t, I'll get negative 1/3 t to the, and I've got to do the same kind of thing we did earlier where there's an ant on my paper. Don't look. Where we took the 1/2 and we subtracted the 1, which was 2 over 2. Here we're going to have the 1/3, and we're going to, oh wait, it's already negative 1/3. And we're going to subtract, so I made a mistake down here. My flexing failed miserably. So when I subtract the 1, which is a 3 over 3 here, I'm going to get negative 4/3. I'm so glad that I tried to show off and messed it up. I think it just proves my point. Maybe just proves the point that I have no business doing this in my head. But anyway. So since it's a negative exponent, notice how the negative 1/3, none of that changes. The only thing that moves is the t. So then our last one here, we've got, I can rewrite y as being x to the negative 3/4. So when we do our y prime and get negative 3/4 x, and we subtract 1 from that exponent, that's minus 4 over 4. I mean minus 7 over 4. So I could write that is negative 3 over 4 x to the 7/4, or the 4th root of x cubed. I mean x to the 7th. Where did I get cubed from? Okay, so we've got, oh good. We're going to go up through rule number 5 right now, because that's enough for this video. So we're going to talk about the constant multiple rule and then the sum or difference rule. Both of these I think are pretty obvious. And then we learned something called the product rule and quotient rule next time that are not obvious. I'm going to want to be a little bit more careful with them. But in all these situations, what we've already been doing still applies. So essentially, if you have something that is differentiable, meaning we can take the derivative of it, and it's multiplied by a number, that's what constant means, then you just do the same thing. You just multiply it, like, yeah, that number's there, you do the derivative, and you just multiply it by that number. So, like, this is 2 over x squared. This is the same thing as saying 2x to the negative 2. So now when we do this and we bring the negative 2 out front, we're doing negative 2 times 2. And so y prime is going to be negative 4x. And we're going to subtract 1 from that exponent again and get negative 3. So I'll say negative 4 over x cubed. Or for this one, there's a 4/3 out front. This one's actually really, really nice. 4/3 x cubed. So when we multiply by the 3, you'd say 12/3, but I'm going to look at it like this. This is how my brain thinks about it. Like we're multiplying 3 times the 4, then dividing by the 3, so let's cancel the 3's, right? If you don't want to do that, you can do 3 times 4 and you get 12 divided by 3. Either way, you get 4x squared. Anytime the exponent and then there's a denominator that matches the exponent, got some nice stuff. All right. So C says S of t is equal to negative t to the 5th. Surprise, S prime of t is negative 5t to the 4th. Wow. Wow. Sorry. I'm fired. Okay. Then y prime, let's see, for this one, it's helpful to rewrite it for a lot of people, so I'm going to be rewriting these as often as possible. Well, these videos are supposed to be as much help as I can give you. So y prime, we're going to take the 4 times the 1/2, 4 times 1/2, x to the, and then we'll subtract 1 from the exponent, negative 1/2. So 4 times 1/2 here. Remember, 4 is over 1, so we can multiply the tops, multiply the bottoms. We can do some cross canceling too. Like if it's on the top and the bottom and it can cancel, then we should. So the 4 and the 2 can cancel, with leave a 2 on top. So we'd say 2x to the negative 1/2. And remember that negative exponents flip, so 2 over x to the 1/2. And just a reminder, if you're going through this video with me, my strong recommendation is to try the problem before I try it, and then see if we match up. Because the best way to get better and faster at these things is to figure it out for yourself. So like this one, start thinking about it, or pause me, or just turn the video off before you let me show you how to do it. Because I'm modeling how I think about things, but you need to be the one to eventually sit down and think through it. So make sure that you're doing that. Okay, so this one, I see that x to the 3rd down there, which remember that's x to the negative 3. So I could think about this as y equals 5/3 x to the negative 3. Notice how I'm making sure to label what this is. This was y, it still is y. Now I take the derivative. Y prime is equal to, oh, this is nice. Because when we bring the negative 3 out front, the 3 and the 3 cancel, and we get negative 5. So remember, we got negative 3 times 5/3. So the 3 and the 3 cancel. So negative 5 x to the negative 4, which remember is negative 5 over x to the 4. I'm a little annoyed that he's giving us these ugly ones to deal with, but I'm also really happy because repetition through this makes them super easy. These eventually will be easy if you do enough of them. FF. I need to make sure I PEMDAS this one carefully. So like, this is negative 5. This is 3 to the 3rd times x to the 3rd down here. So 3 to the 3rd is 27, 3 times 3 times 3. So I can say 5 over 27 x to the negative 3, and that's f of x. I haven't taken the derivative, I've just done some algebra to make this a doable problem now. So now when I do the calculus, f prime is equal to negative 3 times 5 over 27 x to the negative 4. Well, 3 and 27 are both divisible by 3, so I'll get a 1 and a 9 when I divide them both by 3. And then that 4 is going to flip back down, so I get negative 5/9, and there's an x to the 5th. So negative 5 over 9x to the 5th down there. Okay. Okay, so if I was doing this problem, I'd be like, that's not an over square root of t, that's a times t to the negative 1/2. And now I'm going to do the work. So I'll multiply by the negative 1/2 and get negative 20 t to the negative 3/2. Whoa, 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 Canfield, slow down. I'm subtracting 1 from that, right? Which is 2 over 2. So that's why the exponent actually looks bigger that time. So it'll be negative 20 over t to the 3/2. And t to the 3/2 can be written, in case you don't remember, can be written as the square root of t cubed. The little memory device that a friend of mine showed me when we were both teaching, it was my second year teaching. I taught with her and her husband, great people. Anyway, she was like, yeah, if you got something like t to the 3/2, it's like a tree, and here are like your branches, and here are your roots. And the roots are always at the bottom of the tree. And so that just helps us remember, oh yeah, it's square root 3rd power. Branches doesn't really make a whole lot of sense, but I think it's a helpful way to remember it if you're ever forgetting the root is the bottom number, because roots go at the bottom of the tree. So then for this one, 12 over the cube root of x to the 5th. So that actually, wow, it's almost like I planned to say it right there. I didn't. I can't take credit for that. It was just a happy accident. All right, so this is 12x to the negative. Cube root's going to be 3rd on the bottom and the 5th power on top. So when I take this derivative, y prime is going to equal negative 5 over 3 times 12x to the negative. So I'm subtracting 1, right? 3 over 3. So that'll be 8/3. So we'll clean it up and get negative 5 over 3. Oop, forgot about the 12. So the 3 and the 12 will cancel. 3 times 4 gets us 12. So I'll actually get negative 20 over x to the 8/3. There I go. Hooray. That's my y prime. All right. So I'm going to call back to college for me. When I was in college, my college professor, he would repeat this phrase, and it was always unhelpful for me. He would say, the derivative of the sum is the sum of the derivative. The derivative of the sum is the sum of the derivatives. And the integral of the sum is the sum of the integrals. And I was always like, what? Because he talked too fast. And he was very monotone. Good combination, right? Somebody who talks very, very quickly and doesn't have a whole lot of wavering in their voice, and so it's really hard to track them and pay attention to what they're saying. He was also really old. But I'm not an ageist. It's true. Oh my goodness. One day I'm going to be old and I'm going to be like, so to take this derivative, all we got to do is, well, hey, what's the derivative of x squared? Oh, 2x. Hey, what's the derivative of 5x? Oh, plus 5. Hey, what's the derivative of 3? 0. Oh, we're done. Literally it. So it's like, now we're just taking all these like problems that we've just been doing and putting pluses and minuses between them, and we're doing them all at once. So like this one, f prime of x is equal to, x to the 4th, so that's 4x cubed. Then here, multiply by 3, and so we'll get minus, I almost said the 3 and the 2 cancel. Minus 9 over 2, x squared. Here, multiply by 2, so plus 4x, then plus 1, and that's going to be 0, so it's gone. So now you might be understanding how people in class have done this so quickly in their head. And you might be feeling pretty confident right now. I hope you're proud of yourself. Example C is not as easy. We can only do this if it's a bunch of things added together that we know the derivative of. This is not that. This is something to a power. We don't know how to deal with this. So what we need to do is we need to take this and we need to do the algebra to it. So let's see, I got 4x squared Then I'm going to get minus 6x, and then I'm going to get another minus 6x. So that's going to be minus 12x, and then plus 9. Guys, this is not the derivative. This is y. Now to find y prime. Now that it's a polynomial, I can do it. So 8x minus 12. Oh, done. Because the 9 goes to 0. So these last 6, they're just taking all the ideas we've been doing and mushing them together. So here, I'm going to say, well, hey, no, wait, y is 4x to the negative 1 minus 4x to the negative 2 plus 4x to the negative 3. And now I can find y prime. Y prime is equal to negative 4, and we'll subtract 1 from that and get negative 2. Multiply those, and we'll get plus 8x to the negative 3. Then we'll do minus 12x to the negative 4. And so I do want to clean this up and say negative 4 over x squared plus 8 over x cubed minus 12 over x to the 4th. But yeah, that's all that's going on here. If any of those had been given as its own problem, we would have done it, no big deal. E is this two things multiplied together. I can't take their derivatives separately. We can only do that when it's a bunch of things added and subtracted together. And so if I distribute this, I'll get 12 root x and root x together. Square root of x times square root of x. If you need convincing on this, I would love to spend some time talking with you about this. I'll help you understand it. But root x and root x multiplied together is x. And then 6 and 3 is minus 18, and there's a root x there. So this is f of x. So I'm not done because I need to think about this. So 12x minus 18x to the 1/2. So now I can do it, right? Now I can take the derivative. F prime is equal to 12 minus, multiplied by the 18, so 18 times 1/2 is 9. And it's going to be x to the negative 1/2, so I'm actually going to skip that step and write over square root of x. So if you're not sure why that worked the way that it did, I'd say go back to an example like D up here and see maybe how, if you can figure that out. Feel free to ask me though if you can't figure out why that happened. Now I'm like, oh no, did I make a mistake? So we'll have negative 9x to the negative 1/2. We flip that to the bottom and then turn it into the square root. Yeah, I'm okay. Oh, letter F. Why must you exist? Especially with such little space. It says on the top, we need to take x squared minus x plus 1 squared. To those of you who know chain rule, I would do chain rule for this question, but we don't know chain rule. We've never heard of that. We don't know what that is. And it's certainly not, you know, a few pages from now. It's certainly not, did I say a few pages? It's certainly not the next section in the book. There's no way you could ever figure this out. You couldn't Google it. So if I do FOIL on this carefully, or distributing, I'll take my x squared times my x squared. I want to show you guys a cool technique. Instead of like doing the rainbows thing, check this out. We're gonna do times just like we would in the olden days with numbers. So like I can do 1 times 1 and get 1. 1 times x, or that's a minus x, and get minus x. This was a positive 1. 1 times x squared and get x squared. And then when we were multiplying back in the day, we would drop down to the next line and we would put a placeholder 0 in here as we move over. And so now I've got negative x times 1, so that's minus x, and then negative x times negative x, that's positive x squared, and then negative x times x squared, that's negative x cubed. Then we'll drop down for our third digit and put in 2 zeros. X squared times 1 and get x squared. Negative x squared, I get negative x cubed, and then x squared, I get x to the 4th. I like doing this because now we get to add it, and instead of having to hunt for like terms, they're all just here. Yay! Hooray! So that's our numerator. It's all over 2, which if I want to handle that, I have to think about this as y is equal to 1/2 x to the 4th. Like I have to divide all of them by 2. I can't just do it right now because we don't know how to take the derivative of two things divided by each other. We only know how to take the derivative of a constant being multiplied by something. So that divided by 2, I get negative x cubed. That divided by 2, I get plus 3/2 x squared. That divided by 2, I get minus x. That divided by 2, I get plus 1/2. And now, after all that, we can take the derivative and get y prime is equal to 2x cubed, because 4 times a half is 2, minus 3x squared. Multiply that by 2, plus 3x minus 1, because that turns into 0. It was a ton of work, and we haven't seen anything yet. It can get, whoo boy, a lot worse. I'm sorry, did I say that? It gets easier. Everything's easy all the time. All right, our next problem says 8 over root x. So I'm going to rewrite this first and say 8x to the negative 1/2 minus 6x to the negative 1/3. Oh, hey, now I just do my work, right? Multiply it out. So multiply by negative 1/2 and multiply by negative 1/3. So we get y prime is equal to negative 4x to the negative 3/2, because we're subtracting 1, minus plus, oh, the sound effects. All right, x to the negative, let's see, we're going to be subtracting 3 over 3, so negative 4/3. I don't know if you all can see the fly that's hanging out with me. So x to the 3/2 is down here, and then plus 2 over x to the 4/3 is there. Hooray! All right, 2 more to look at, and then we'll be done today. So 9x minus 3 root x over x. So we talked about this in class yesterday, just to verify. 1 plus 4 over 5. 1 plus 4 over 5 is equal to 5 over 5 is equal to 1. That is true. What about 1 over 5 plus 4 over 5? If I take this and split it up, is it still true? 1 over 5 is 0.2, 4 over 5 is 0.8. So yes, that is still true. But what about the reverse? What about 5 over 1 plus 4? 5 over 1 plus 4. That surprised me. 5 over 1 plus 4 is 5 over 5, which is 1, right? But is it the same if we do 5 over 1 plus 5 over 4? This is 5 plus 1.25, which is equal to 6.25. This is illegal. So notice the difference. When the plus is on top, we're allowed to break it up. When the plus is on the bottom, we cannot. It is not true. So this, I can literally rewrite it as 9x over x minus 3 root x over x. And you might kind of think to yourself, well, gee, that's terrible. Why would I want to do that? Well, here the x and x cancel, and they kind of cancel here if you're careful, because this is really 3x to the 1/2, and this is x to the 1 down here. And the way that we deal with division and exponents is we take the top exponent, we subtract the bottom exponent. So I can rewrite y as 9 minus 3x to the negative 1/2, because 1/2 minus 1 is negative 1/2. And now I can take this derivative. The derivative of 9 is simply 0 because it's a number. And here it's 3x, so, or negative 3x. So I can multiply by the 1/2 and get negative times a negative is a positive. So 3/2, x to the negative, we'll subtract 2/2 and get negative 3/2. So I'll say y prime is equal to 3/2 x to the 3/2. All right, final one. This the plus sign's in the bottom, so I guess we just quit. No, I'm gonna try factoring, and in the very near future, I'm going to apply something called quotient rule. There are multiple ways to get the same answer in calculus. This is one way to get this answer. So using just the tools that we have, we're going to get this answer. So I'm going to try to factor the top in I. Let me just kind of clear this off. So the top in I. So if I'm trying to multiply out to this, I need to multiply to negative 16 and multiply to x squared. So I already know I'm going to need x and x, but 16, this could be 4 and 4, it could be 8 and 2, it could be 16 and 1. There are lots of options. What we then need to think about is when we FOIL this out, we're going to get a negative 6x in the middle. Well, the only way to multiply to a negative was a positive and a negative, so I already know it's going to be plus and minus. And then to figure out that in there, if I tried 4 and 4, it'd be like 4 and 4. When then we want to multiply it out, we're going to get a 0 in the middle, so it's not 4 and 4. I already know it's not that. 16 and 1, when I do that and FOIL it out, we're going to get like a 15 or a negative 15, so that's not going to work. But 8 and 2 does work. I just need to figure out with 8 and 2, which one of those is going to wind up being the negative and which one's going to be the positive. If you look at winds up FOILing out to negative 6, that means that the bigger number is going to be negative, and so it's going to be x minus 8, x plus 2. Down here, they both have a 2 in common, so I can factor the 2 out and get x plus 2 inside. This leads us to cancel, and now it's x minus 8/2, otherwise known as 1/2 x minus 4. We're dividing them both by 2. And again, that's because it was a sum upstairs, not a sum downstairs, that let us do that. So now I can take this derivative. Y prime is equal to, are you kidding me? Oh, that whole mess, at the end of the day, y prime is 1/2. All right, this is enough to get you through number 18 of the homework. So everything we just did would get you through number 18 of the homework. I'm not saying that that's what I'm going to assign or what your teacher's going to assign, but that is for that. So hope this was helpful. Have a great day. If I don't see you, have a good 3-day weekend. But you know, if you're watching this in the future, then who knows when this is happening. Okay, bye.